Alright, so we've established that we can go about it like this, and that's really long and cumbersome and doesn't work. Or we can use this substitution method where we substitute u in, where u represents a function inside our function. We derive u, and what do we get? dy to u equals 3u squared, and du dx equals 2. Now what do we want? What's the whole goal? We want, what have I asked us to do in this question? Derive it, which is, we want dy dx. So how does dy du and du dx help us get that? What's going to happen there? Specifically around the du's. They cancel out. So does the left hand side equal the right hand side there? Dy dx equals dy dx, so we're all good. So am I allowed to do this? Dy dx, what? Dy dx equals 3u squared times 2. Am I allowed to do that?
Yeah.
Which equals 6u squared. What should I do with that u, you reckon? Leave it like a u? Substitute my original back in. Remember to keep the bracket, so I've got 2x minus 4 squared. Sweet. What do you reckon would happen if I factorised that and took out all the common? I'd get this, wouldn't I? Same thing. We can see that 6, and you're going to have two lots of 2. 6 times 4 is 24x squared. So you can see I don't really need to go through and unpack that. Does that make sense, bro? That there is called the chain rule, and it's the first rule that you're going to learn about deriving. So when did we use it? Why did I use it? I had a function inside a function. So I had something that was too complicated to derive inside a power of some variety. Cool? So something that I couldn't do. I can do this by itself, and I can do something to the power of 3 by itself, but I couldn't do them both together. So I apply that substitution, apply my chain rule, and off we go. Cool? Do I expect you to understand that right off the bat? Not really. So we'll do some practice questions and see how we go.
The